You are.
So now I feel the pressure of summing it up in a clear way. Yeah, we pretty much talked about OpenEEW SVF anniversary now, and feeling sort of being stuck with some parts of the project. And that dashboard is now the dynamic one, but the other parts have slowed down significantly. And we feel the need of getting OpenEEW to the version 1 as soon as possible, and having it as a version that we can sort of build up on in the future. And we were thinking what needs to happen before we get to the version 1 and how to get there in the most efficient way. And we started to talk about Puerto Rico and the problems in there that may have something to do with firmware, but also it may be something with the internet in Walmart. And we just don't know. I don't really know. And Andy and John are definitely would know more about this. But also we said that some costs that are related to the Watson IoT may be because I think that we have sort of redefined a little bit over that past year how we think that OpenEEW would work. Like, we started with that idea of creating a global network that would be denser in certain areas, but it would be under the umbrella of OpenEEW/Grio, but the system would be the same for the whole world. And then I think we found out that it's not likely work this way, and that we need to have networks that are local in different regions. And therefore, I think that we have sort of redefined we also need to redefine a little bit our needs, and some of those components that we are building in certain way may not be used exactly in the way what they were designed for. So I think that we sort of need to think about some of those components. And so yeah, like going from the sensors up to the cloud, I think that or what we talked about, that we do find some costs, or that for us as Grio Puerto Rico, and also for probably my project that I'm planning in Nepal, the Watson IoT costs may be quite high and not really sustainable. And so we would be considering switching to AWS, because we do have some credits, and it would be cheaper. And I think that, so therefore, I don't think that the whole OpenEEW needs to change significantly for that, because I think that OpenEEW, as we understand it, and we can also have some discussion about it, but I think as we now understand it, is the set of technologies that should be probably quite agnostic to where they work. But then there is that application of the technology, and the application is, for example, Grio's application in Puerto Rico, or Geophysical Institute in Prague application in the network in Nepal. And those particular instances, they just need to pick their own providers based on cost and abilities of us to cover that. So, but I think that we should probably try to make at least this MQTT component, because that's probably quite a straightforward one. We should try to make it agnostic to the particular cloud service, because hopefully there would be more networks in the future that is not probably, or some of them may be run by us, but some of them may not. But we should probably let people to choose their own providers of those particular services.
Which could even be a local MQTT broker, as the folks in Chile were really keen, no cloud. So I think, letting people choose.
Yeah, so that was a summary that I wanted. And sorry.
I like the idea of having a modular approach to trying to let people pick where to send the data, what MQTT broker. But the truth is, the firmware is very much dependent, especially from a security perspective, on getting the broker sort of, whether you pick Watson IoT or you pick AWS or you pick a local broker, you take different paths in the firmware. Now the topics can be the same, the algorithms can be the same, and the network recovery stuff can be the same, but the actual implementation of that MQTT broker turns out to be different. For now, the library is the same. It's just like what you feed the app from AWS or from a Watson IoT or from local. That's where the devil's in the details there.
Well, so when I created that variant, and it's very rough around the edges of AWS to test this out, I just basically used exactly the same pub sub library, and all I did was I effectively added 2 new certificates, which are the client certificates, which the pub sub library handles quite well. But everything else was the same. Like it starts the MQTT broker.
Yeah,
just
but you already knew the certificate, right? And
yeah.
That's the hard part. And the same thing on the Watson IoT side. I had done all this work to do activation, dynamic activation into IoT platform. So you register the first time you register the device and you give it a password, blah blah blah. All of that was sort of behind the covers. That I totally agree. I just realized it's dependent on and there's for sure it's just code, so we could figure out how to do it.
For me, Watson is the odd one out though, because when I created firmware in Azure, or when I created it in Mosquito, or when it with certificates, or when I've created it in Vern, or when I've created it in AWS, I've always just added certificates manually. So if the only way to connect to Watson is through a sort of automated system, then that would seem to be the odd one out of the other brokers.
Oh no, you could generate certificates with IoT platform as well, Watson IoT. But that's the hardest. I always thought if I'm doing 100, I don't want to generate certificates. I was trying to do the automated stuff so we could not have to do the unique certificates for each device.
Got it.
I think what we learned is that we, especially for Puerto Rico, we should have just done the shorter path, which was generate a certificate, flash the device for that location, send label the device for that location, and send it to the people that would go tape it to the wall.
Yeah. It's less elegant, but it's.
Well, if we were to think up of a dashboard solution to the provisioning process, because what we should also do today is try and figure out, so what exactly, what is the shortest path with the components that we have right now to get to a version 1.0 end-to-end with everything, right? Because then we can always, expand from that, right? And build more onto it. It's just that, we probably should be approaching, considering the number of sensors that are currently in Puerto Rico, and considering we've been doing this for a year, we probably should try and just get to a point where we have something that works end to end. So we know that the provisioning process is a bit of a limiting factor, right? Because people are having trouble. You can't use the provisioning app if you're on an iPhone, and people are having trouble sort of across the board. So if we were to create some sort of dashboard solution for provisioning an app, at least as a backup, what would that entail? So we definitely can take any information we want and put it into a form, right? And save that to the database. But then what are the sort of MQTT considerations that we would, and the firmware considerations that we would need to have if we did it via the dashboard?
Before I answer that, Ryan, I think the first part of the question I would like us to answer as well, which is what is missing, right? So before we get into a whole about firmware, let's talk about what is missing, because we have at the moment, potential gaps in MQTT servers. Like other people, there's different people have different requirements for MQTT. So I think that's one. The next one for me seems to be this Václav's work, and Václav, you've actually been developing a system now for using seed links, so which basically reads MQTT messages, turns them into seed link, and that allows you to use well-established tools, from what I understand. So that seems to be another one, which is how can we implement that in our architecture? And then for me, the final and missing piece is some Twitter account, some way just to see the alerts coming out, or the dashboard, or whatever it is, but some messaging system where people can get to the alerts. I feel like we have big holes in those areas.
So that's basically three things, right? Provisioning, seismology, and alerting. And I know it's like, let's just fix those three things, but
this is a good 1-year anniversary.
Yeah. The three things that define the entire system.
Sensors, seismology, alerts.
Yeah, we only have 9 things to fix. But a lot of this stuff is already built, right? Like the provisioning app doesn't need to go away. It just, maybe it would make it simpler if we just had a backup way of doing it. So in case you try the provisioning, because the provisioning app, by the way, when it works, it really is just straightforward, right? Mine has really never not worked. And it's an easy way to provision the sensor. It's just that if it fails, there's no error handling. It doesn't tell you why it failed, then you can't do anything after it. So you're just sort of stuck. So as a backup, we could at least do something through the dashboard if it's simple enough. The seismology,
and we have a lot of people who know how to do web, so we can develop that piece in an easy way. Yeah.
Exactly, and then Václav, the system that you are putting together for seismology, so would the end result of that be the same as what it is now in like the clouded database, right? Where the events and the detections are written to the database?
Yeah, it doesn't change. I'm now rewriting it a little bit because as the time goes on, I always get new ideas about how to be done. So I've been like rewriting it a little bit more to utilize OpSpy, and as Andy was saying, I would like it to data flow some slightly differently, but the end result is going to be the same. So I don't think that there is.
Yeah, because
unless you want to change.
Yeah. Once that event gets created, right, from the seismology script, that could be the source of the alerting, and that's the really final piece of the dashboard, because then that fills in the events page. So like, and the seismology doesn't really need to connect to it, as long as the end result just ends up in the cloud database, then that's sort of solved, right? Because that's such a like modular piece onto everything else that all we need to do is just basically, launch it, and that's and that portion of it then feeds alerting in the dashboard.
Seismology is not too far away. Like I can probably once we have all the data flowing in, which now we are having troubles with, but seismology is not far away at all. Like it was pretty much working before. I just was waiting for some final call on the MQTT, and then I got sidetracked and started to rewrite it again. But like right now, it can work in that previous version.
Yeah. So that's good, and the dashboard is sort of in the same situation. I mean, there's a few things that we need to do with it, but it's slowly coming along. It just needs just a little more momentum to get it over the finish line. So really, it comes down to the provisioning. The provisioning is the big block to really having like a confident 1.0 system.
So I'm sorry if you were. One thing that I don't really understand, but maybe we or those people who do understand it, maybe they can think about it again. Like, do we need the same authentication for like sort of the newly defined OpenEEW system as we needed for the old OpenEEW system? Because I can imagine that right now we have that login button on the dashboard claiming a sensor, and that's part of and I suppose that's quite a complex part of the backend of the provisioning app, claiming the sensor and stuff. And I think that maybe a thing that we might not, or like linking the sensor to an account and all these things, maybe there are some things that can be done significantly simpler,
Well-
given that we are having separate networks and
So-
not multiple owners of 1 or 2 sensors.
So this is what I did, because I'm not as skilled as John, is when I created the sort of the variant of the firmware in GitHub, I took away the provisioning process, and it's very straightforward. The device, I just figured the device identifies itself with its MAC address, which we can extract very easily. In fact, you can probably create a Raspberry Pi as an AP that just reads the MAC address, and then what you do is and then what it does is it just uses certificates that you've pre-installed. It connects to in this case AWS, and then MQTT, and then that's it. That's all you need to worry about. And then all we care about is associating that MAC address, which would be stamped on the case, with an address in the database. So that part is easy, and I've done that part, but it's not as elegant as maybe the firmware we have. And as John mentions, it'd be nice if we could have a sort of a single firmware, so that when things get updated, they all do together, and which could be modular. But I see the authentication as being something that you should be able to switch off, because it's quite straightforward just to identify it by the device ID.
Yeah.
Cool. So if we were to, for example, like using that, what I've never really understood, and maybe it's the reason why I'm like asking a lot of questions via this, is like, how does, in the provisioning process, how does that create a connection to, with the provisioning app, how does that create a connection to the MQTT broker?
It doesn't. So the provisioning app does an HTTP put to a Node-RED endpoint, which writes additional information to Cloudant, including location, email address, owner name, right? So all the attributes about the where, so longitude, latitude, ownership. Then, so that's sort of the provisioning ownership part. The provisioning app also sends the data, the Wi-Fi data, to the device, so that it can connect. So when you plug in a new device on a new network, it doesn't know SSID or Wi-Fi password. So the app also does that. Now, once the app gets once the firmware or the device itself gets the Wi-Fi details, it just, for the first time, it hits an activation endpoint, and Node-RED flow talks to Watson IoT, creates the device, and then writes the rest of the details to the Cloudant database, and all gets merged up together in the Cloudant database. And that's what you read out of the Cloudant database to build the dashboard. So,
one thing I'm forgetting here. So the Wi-Fi details are sent to the device via the provisioning app. So if we were to do it via a dashboard, you would need to enter your Wi-Fi details into the dashboard.
Well, the problem is you got to get that to the device, and that was the original point of the provisioning app.
But you can use any smart config app, like the Grio Plus app or the Espresso app. There's a million apps that will do that for you, it's just 1 or 2 lines you add to the code in the firmware. So you can have the smart config without, if people want to use Wi-Fi, without having to go through the whole authentication process.
Yeah, I did it with the 20 sensors that I meant for Nepal. It created some extra work for John. So sorry, John, for that, because it didn't.
But that was easy.
It didn't fill out the whole database in the backend with the authentication stuff. But the smart config, the generic smart config app, worked just fine for all the 20 sensors, no problem.
And the great thing about smart config is that the vanilla smart config has got all the error handling and issues and messages, and so it's pretty. If all you want to do is pass Wi-Fi details to the device, that part is pretty straightforward, without us as a community having to reinvent it.
All right. Hey guys, I gotta jump.
Okay, John.
All right, we'll see you, Jim.
So,
So Ryan, just to answer that question, yeah, I worry that we're trying to create too much of a polished, authentic provisioning process. Like for me, does it need Wi-Fi? If so, use a pre-existing app, which everyone can use, is always well maintained. Otherwise, use Ethernet. The firmware can handle it. And then the point at which we have to claim ownership of the device, it's fine. It's got a unique identifier which we, in the web or wherever else, claim.
Yeah, that's what I'm trying to figure out is what is the simplest solution to doing it from, let's say, like a web app. I mean, and I keep reiterating, like, I don't want to get rid of the provisioning app. I just feel like there should be a way of doing this in case the provisioning app fails, right? Because the provisioning app is easy to use when it works.
But in Puerto Rico, out of the sort of 5 people that I've had to educate on how to install sensors, all the questions about the provisioning app, that's always been a massive problem. Always. Yeah. It's just different devices, different, like sometimes in a bad Wi-Fi situation, 5 gigahertz, open Wi-Fi's with no password was an issue we had at Walmart. There's all sorts of things are coming up there.
So I guess, I mean, all I will say is that just trying to figure out some way to do it, let's say from the dashboard. I mean, I just have to like think through of exactly what we would need to do that, but I'm sure it's possible.
So what I was thinking that and I might not think about everything, but what I was thinking is that first, like you need to connect your sensor to the internet, which is either Ethernet with no configuration because it's already flashed. So you just plug it in and start sending data to the endpoint, which is already pre-configured. That's flashed. So that's always going to be the same. And or also maybe in future configurable, but it doesn't need to be. So either it's just plugging in Ethernet cable, which is simple, or going through some generic smart config app, which is also quite simple. And that connects the sensor to the MQTT endpoint, and it starts receiving the data. And then what I think that is the only thing that you need to have, if you have multiple instances of OpenEEW networks, for example, GRIO in Puerto Rico, a Geophysical Institute in Nepal, they want to claim the sensor, and I think, and give it some, the location, and also there's going to be network code and station code and stuff like that. So in order to do that, I think that the only thing that you need to do is to put some like add sensor button where you type in, for the first time, you type in the whole MAC address, and it links the MAC address, which is going to be unique, and nobody will ever guess that, so nobody can ever steal you the sensor. It adds it to your particular instance, like network, and then you can configure stuff like location, latitude, longitude, and that would be pretty much just filling in the database in the backend. But
yeah, I mean that works. Yeah. Can I just ask though, how does the because I don't know myself, so how do you connect it to the Wi-Fi? How do you tell it the username and password when you're connecting it to the Wi-Fi through those methods?
You don't send username and password. What smart config can only send Wi-Fi details.
No, I mean maybe username and password is the wrong. How do you send your Wi-Fi password via those those configurations?
So yeah, well, Andy knows better than sorry. Yeah, so the smart config app like connects to ESP32 and then tells it you just type in actually it reads up the network that your cell phone is connected to, and you give it a password, and it sends it to the ESP32. So it's actually very straightforward.
So really we could just divide up the connection process with the add your sensor to the dashboard process, and they could just be 2 separate things, right?
I think that would be the easiest thing, would be connected to the internet. If you have Ethernet, just plug in the cable. If you don't, go through this smart config app, and then like once your sensor is connected to the internet, it already starts sending data, or if it's on trigger, it doesn't start sending data, but it's already connected to MQTT. And through dashboard, you would just need to claim the sensor by typing in the MAC address. So, and that would link it, because so it would not be absolutely bulletproof. Somebody in theory can guess your MAC address or know MAC address, and once you connect it there, they can steal your sensor by typing the MAC address before you do. But I don't think it's very likely that would
That's not going to happen, and it'd be very easy to remove them on the database if they do.
And the provisioning app already has a way where if you just put in a different email address in the provisioning app, it'll assign it to your account, right? So there's already somewhat of a security flaw there that I think we've just accepted, because at the end of the day, it's ground acceleration we're talking about here, not necessarily the personally identifiable information or anything. So yeah, I mean, that makes sense. And then having the provisioning app develop as it's going to develop, right? I mean, it's like, if we just had that as at least a backup, we could also put some instructions like built right into the dashboard if we wanted for how to do all that stuff. And then if the provisioning app, reliability becomes better over time, then people have that as an option.
Yeah, I agree. Yeah.
Yeah.
Cool. So yeah, to do that, I would need. I think I just need to do it myself, right? I have a sensor, and I just need to understand the process myself of connecting it via the two ways that. So you said smart config.
Yeah,
and then you can just connect it via Ethernet, right?
Yeah. Don't get too worried about the connecting it to the Wi-Fi. Basically, the device, connecting it to Wi-Fi, you could even hard code your Wi-Fi details into the app. It's quite straightforward. But just using smart config, I'll give you an example. Grio has a Grio plus we have an app which does just that. Or do you have? Sorry, 1 second. Let's take. So if do you have a Android, Ryan?
Yes, I do.
Well, Americans had Americans had the other one.
I bought Android because it was like I didn't want to spend $1,000 on an iPhone.
So here in the thing is the Grio app, which is just for it's basically a reskinned version of the smart config app, and it does nothing except put your Wi-Fi password in. As soon as you connect it will identify your Wi-Fi, and then you put your Wi-Fi password in, and it will send it to the device. So all of our firmware has that protocol built in, so they will all receive that. The variant that I created, if you want, I can send you my secrets file if you wanted to use the AWS broker. The variant I created actually bypasses the authentication, so it's actually easier to do this, because all that does is you give it the smart config, it will then go straight away, start sending data straight away to AWS MQTT. And within the JSONs, it has the device ID. So all we would have to do somewhere is, associate the device ID with the user and the location.
Yeah. Okay, that might be a 1.0 provisioning process.
Yeah, super easy. Let me if you start doing that, we can chat in Slack about it, and I'll show you what I did with the firmware.
Yeah, that sounds good.
Because if you just try to use the Watson IT firmware, you might have an issue, because it does require you to go through some steps before you can connect.
Yeah. Yeah. Let me when I start looking into that, let's talk on Slack.
Okay.
And then alerting, I mean, the alerting portion of this is probably the easiest to consider, right? Because we don't have anything built with it. So it's very easy to, say, we'll just build it nicely and and just leave it at that, right? But
I thought we just need to have a tweet going out. That's all we need. I mean, we can get fancy, but your version 1.0 is just a tweet, right? Which everyone here can subscribe to.
Yeah, I mean, some sort of messaging system. Actually, yeah, Adrian, didn't you have it connecting with Twitter until they, I think they had a problem with it or something like that?
They banned me a couple of times. I should run for a presidential office or something.
Yeah, no, you're in the club now.
But I don't know if I got unbanned, but yeah, writing the code for it is I would say nearly trivial if you're familiar with how to subscribe. There's an API called Tweepy, whatever, and it just pretty much connects you to Twitter. You just make a post and that's it. It's pretty easy. I think it was under 100 lines of code total with 2 scripts. So that's the most simple case, right, where you are going to predefine Twitter account, which is, I think, absolutely fine for what we're trying to do for the 1.0. You just got to make sure that you're correct about what you want to tweet on, because that's the most dangerous part, right? I mean, you can subscribe to any topic that we produce, but it's what information on the topic do you actually want to tweet on.
So why did they ban you or at least suspend you? What was the cause of it?
So every Friday they have some automation that flags people or accounts that they view as suspicious, and then they ban them. And then I send them an email that every Friday, and then I'm like, yeah, why did I get banned? I only posted this one thing. And then on Tuesday, someone, like a real person, messaging back, oh man, you just got caught up in the automation. It's all good. We unbanned you. And then the next Friday, I got banned in the exact same thing. And I sent the email again, and I'm like, look, this last guy said this thing. And then it happened 3 weeks in a row where a person apologized for it. And then I was like, all right, I don't need to keep testing this anymore.
We just build an automated process that then writes the email to get back into. It's just life in the 21st century is just automated ban and then automated email to get you reinstated every Friday and Tuesday.
It's like, come on, man. I don't think there's any, Russian spies living in Cary right now where the tweet was originating from now, but it should be fine. I mean, one of the things I would say the hardest part is getting Twitter to let you actually send tweets automated, because they have this whole big process where you gotta like write an application, tell them what you're using it for, and there was a lot of back and forth on that, because I was like, yeah, I just want to learn how to use this, and they were like, that's not really good enough, and then I was like, well, that's not good enough. Yeah. So, but anyways, it should be fine. I mean, the code's in GitHub right now, so it like I said, I don't know, Vaclav, if you have a suggestion on what things we should be tweeting on.
Yeah, I'll have a look at it, what you have put in for now. And yeah, I think that we should probably just tweet that, like approximate location, magnitude, and time, and just that this is a test alert and not a real thing that people should take any action based upon.
Yeah, all right. So yeah, the base stuff has that. I think one thing too is, if I remember you guys mentioned that you may want a graph or something. So you could generate that too. I didn't do the graph.
What graph? Sorry.
So I think there's the Grillo account tweets some kind of chart or whatever.
Oh yeah. Those waveforms. Yeah. I could create something that could display. Yeah, maybe a display of. I can think about it.
Going back to Ryan's end-to-end thing, just having a message at the beginning saying this thing happening, I think, will be a good starting point, right? I mean, there's all sorts of ways we can get fancy, and maybe Twitter might not be the right way. So just having an initial message popping out, I think is good enough, right?
Yeah, because we need to test this out, and it needs to have a while before we start actually building, I think, more official ways of alerting, right? I mean, we talked about caps and all that, but you need to make sure all the stuff works before we actually.
Yeah, agreed.
Yeah, definitely.
Yeah, good. So it's quite a few activities then for us to get to this 1.1. Yeah. So that stuff. Your backend. So if I missed the conversation, I had to step out for a second. Your stuff, the Seedlink stuff and the ObSpy stuff. You think that can just sort of sneak in the way it is, or you just have to change the MQTT broker that it talks to, and then you have to. Is there any work you need additionally there?
I'll think about, because I think it would be nice to, well, the system could stay as it was, but I think it would be nice, for example, for Puerto Rico, so they can access our data in real time, because they have that Airform system that they are running, and they would like to have a real-time access to our data. And that's why I was setting up that Seedlink server. And when I set up the Seedlink server for Puerto Rico, like, we need to think about like where that's going to be hosted and stuff. Like, if that's right now, it's running on a Grio AWS, but it may run, like, we can think about it or talk about it. But I think that if that is running somewhere, what makes the most sense to me is that seismology scripts that are now running in Kubernetes, or will be running, they are not running right now, will be getting also data from this Seedlink server. And so I still need to do a little bit of work on that. It's not going to take too long, but I'm on vacation next week, so I think within 2 weeks I should be able to finish this up, because it does require some work, but it's not a huge change of the seismology scripts. So, sorry, what was the question?
You answered it.
Okay.
What needs to be done? That's good. Okay. Well, if there's nothing else, guys, is there anything else? What have we missed?
Comment. Didn't you just come back from vacation, Vaclav?
When will I be back? Sorry?
No, I was making a comment. Didn't you just come back from vacation?
No.
Oh.
That was Andy. Andy went to
That stuff does go hiking quite frequently, though, I've noticed.
Yeah. I was having these extended weekends, but yeah, no relocation.
trying to plan a vacation myself. That's
So you work from home. Isn't this like a vacation? It's like a nice prison.
Yeah,
it's
like house arrest.
Right, exactly.
So Ryan, after this report about the climate change, I sort of think you need to get out of LA.
Yeah, well, I mean, gotta move off the planet if you really want to, really want to escape it.
Apparently, Michigan and the northern states, apparently that's a good place to be.
Yeah,
they have water over there.
Yeah, they
have water. Exactly.
Yeah, exactly. So California, yeah, it's tough. I mean, wildfires and whatnot. And we've been thinking about moving to the East Coast for a while, but it would probably be the southeast in the United States, which is getting warm too, and has to deal with all the hurricanes.
You got to move to the middle, man. That's so. In the Northeast, they're getting a lot of water. It's hot as hell in the South, and then in North Carolina, we get nothing.
Yeah. My father lives in Syracuse, near Syracuse, and that apparently is a great place because they've got all the Great Lakes nearby. Nice sort of like temperate climate.
I used to live in Boston, and it's great in the summertime. I mean, it's 68 degrees.
Oh yeah. So I guess I don't know. I haven't actually done that much towards OpenEEW since the Burn MQ stuff. You guys need me to do anything? Probably not. Talking about like infrastructure-wise, GitHub Actions.
I mean, we probably should.
Nothing.
There is a like 75% done PR that I have on my computer somewhere that actually uses a production build of React and deploys that to Kubernetes. But so that probably, to finish that out, I might need your help, Adrian, on. But for now, I mean, like, just getting the end-to-end system working, even if it is a development version of the dashboard, is, I think, the priority.
All right. Oh, so I guess a comment, you guys were talking in the beginning about the letting each region potentially host their own system. So, pick their own provider. there's a way that you can actually facilitate making that a little bit easier. So I didn't give you guys a script, though. I didn't put it into GitHub, but there's a technology called Terraform, where you can actually write some scripts, and then it sets up infrastructure, and it supports every cloud instance. So it works for AWS, it works for IBM Cloud and Azure, etc. I have one for IBM Cloud, and it just sets up like the things all the way up to the point where you have Kubernetes. Then after that, you can make a Helm chart that installs all of the microservices you guys develop. So the reason why I'm bringing this up is if you really want to make it easy on the people who want to set this up themselves, those two things would help a lot.
Oh, that sounds awesome. That sounds
That would be
great.
perfect.
Yeah, that'd be great.
So Terraform is like CloudFormation, but for every cloud?
Yeah, pretty much. Yeah, and then I don't know if you guys know about Helm charts, but they're essentially it's a Kubernetes package manager. So it just takes the Kubernetes YAML files and then deploys them to whatever Kubernetes instance you want to point to. So all right, so I mean that being said, I can push up the ones that I made for IBM Cloud, and then. I mean, I don't know. I don't have access to AWS, but we could just pretty much create a repo that has the Terraform scripts for each cloud provider if you really wanted to go down that path.
That sounds great. The only issues I would see is that if people wanted to replicate everything, they're gonna, like there's no equivalent for Cloudant in AWS, and there's no equivalent, so we are dependent on some IBM services, and it would be quite a lot to try and.
Well, you can use CouchDB, can't you? Because we were going to use that locally anyways. That would have to be part of the deployment. Like you would have to put it in a Kubernetes container.
Yeah, right. You can run it for like JSON documents like that. You can even use DynamoDB because you can basically just use a library to transform anything going into DynamoDB into just JSON, right? And you can just use like MongoDB-esque tools to communicate with the database. So there's basically an equivalent to Cloudant in every cloud platform. But yeah, probably the biggest thing on the dashboard is that the dashboard is very much built into App ID, and to make that platform agnostic would take a little bit of work, but it's all doable.
Well, maybe there's some synergy across the different cloud providers, because that's kind of the goal, right? That's why you can move from IBM to Azure and to Google Cloud Platforms, Kubernetes, because they made them similar. I don't know if there's an App ID equivalent on the other providers that's the same or whatever.
We've used Cognito in AWS before.
Yeah, it's Cognito. They all have their own.
I'm sure they all have. Yeah.
They all have the same stuff. It's just
Google is Firestore, isn't it? Fire something.
Firebase, yeah. Google. That's a whole like authentication framework. Cognito is the most analogous to App ID, where it basically is just a store of users, and then you authenticate against that directory.
But at the same time, Ejin, don't dive straight because you're, because I would worry that if you start doing all this now, there's a lot of work, and I'm not sure yet which elements. I think we need to discuss it a bit more, right, Ryan? Which elements are the ones that we want to translate rather than dive straight in and start translating everything.
And I think the greater goal right now is just to get to like the end-to-end system that works using as many components as we have right now. So we can use App ID for like, we don't have to change that now, right? We can, the MQTT stuff, obviously we could be a little bit more, that we could change around because we don't have that really solidified yet. But everything else, we can just take what we have now and try and get it running and then go from there.
Sounds good.
Yeah, I agree.
Cool.
Okay. Well, if that's that, I think that was a good review of 1 year's worth of work.
1 year. Yeah.
For the next two.
Yeah.
Sure.
Yeah.
Okay, guys.
All right. Have a good one, everyone.
Take care.
Take care, everyone. Bye.
Yep. Bye, Pedro.
Bye.